All right, let's talk about the base change formula. First, let me tell you why we want to know about it. So, as we talked about a moment ago, we have log base 10 and we have log base e, which of course we write as the natural log. But most calculators only have those. In this problem here, we have base 2. We could have any base. So the base change formula allows us to change to a base that we have. So most of the time, of course, we'd like to pick base 10 or the natural log. So let me give you an example of how we can find the log of this. So the base change formula, so in this example, we start off with a 2 here. And so for the b, we want to pick either base 10 or e. Let's do it both ways. So I can rewrite this as the log base 10 of 5 divided by the log base 10 of 2. So the lower number here, the subscripted number, is going in the denominator. And our 5 here is going right there. So now you can just take your calculator, and please do this. Go log of 5. And if you're putting this in your calculator, you'll want to make sure that you close the parenthesis right there. Divided by log base 2. Excuse me, log of 2. So that should give you 2.3219. Now again, we pick log base 10 a lot of times because that's convenient. But here, let's try it again. We can also use the natural log. So we can do the natural log of 5 divided by the natural log of 2. And go ahead and put that into your calculator, see what you get. And even though these two numbers will be different, this number and this number are going to be different, the end result is going to be 2.3219. So you'll find the base change formula to be pretty handy. Let's talk about some applications. So calculating pH, in chemistry or something, it's pretty common. Just a quick refresher here. So here's pH, and 1 means it's really acidic, or better yet, 0. And then 14 means it's really, really basic or alkaline. So here's an example. So first, let's calculate the pH. And this is the equation we use right there. So in your calculator, all you have to do is actually so I'm saying, okay, here is the concentration of the hydrogen. And we just need to put it right into our formula. So negative log. And in your calculator, you can go 3.5. It's going to be easier if you find that E key for exponent, negative 5. You can write it out this way if you want. It just takes a little more time. So go ahead and try that, and you should get negative 4.4. I'm going to round it to 6 right there. So we're saying that the pH given this concentration is that. Now let's try to do the problem backwards. Let's start off with being given the pH, and let's find the concentration of the hydrogen atoms. So we have 8.8 is equal to negative log of, and then here's the concentration of the hydrogen. And it might be easier just to put this in as an X. So the first step would be to divide by the negative 1. So now we have negative 8.8 is equal to log of, and I'll just use x here. And again, this what's implied is base 10. So now let's rewrite this in the exponential format. So we're saying is that this is 10 raised to the power of negative 8.8 and that gives us then x is equal to 1.58 for, I don't know how many decimals, times 10 to the negative 9. Now let's go through some other examples of logs that'll be in the assignment. So the first one here, notice we have addition of these, and some of you might be thinking about using one of those log properties, but that's not what we have going on here. This one simply be then rewritten as the log of 5 plus 2 gives us 7. So just a matter of hitting the log 7 button on your calculator. This one here, we have two ways of doing this. One way, of course, is the direct way. We can just go log of 10. So that'll just give us a 1. The other way, though, using the log property that we talked about earlier, multiplication can be broke up into two addition problems. We could make this as the log of 5 plus the log of 2. And just to show you that works, let's actually do this on the calculator. So I can go log of 5. If you do that, be sure to put the closing parenthesis in there, plus the log of 2, and you can see that that's going to give you a 1 as well. I mean, personally, I think you might as well just do it the easy way, but I wanted to remind you that that is a log property we've talked about recently. Okay, let's do one more example here. This one we could again do two ways. One is just very direct, go log of 5, and it'll be easier to use that E key on your calculator. 2. And go ahead and again put that in your calculator. So log of, so that gives us 2.699, or again, just like above, an optional way of doing this, and I'm not really encouraging it, but I want you to see again the log property is we could, anytime you have multiplication, you could break that down into addition problem. So we could say we have log of 5 plus the log of 100, and you know that the log of 100 is 2, and the log of 5 is going to be 0.699. So our final answer would be, of course, the same, 2.699. Two ways of doing it. All right, so here are some more log properties, but this time let's go and work again with a little bit more with the natural log. So the best way to figure this one out is to rewrite it as an exponential. So again, remember, this is essentially base E, so we're saying E, and I like to put a equal sign on all these here. I think that'll help you out. E raised to the power of x is equal to e to the third. So you can see, right away that x is equal to 3.